Back to the channel. This video is all about focusing with donuts. So if you have a scope with a central obstruction, it will, when you move out of focus, turn your stars into donut shaped rings of light. So this video is all about how you can improve focusing with some new functionality if you are suffering from the donut problem. So if you have a refractor, this isn't going to help at all because they don't create donut shaped stars. So it's going to be hopefully useful for folks with SCTs or Rejection, RASAs, Newts, etc. Anything that has a central obstruction that will create a donut when you're out of focus. So folks from the forum have been helping with this particular project by sending in some data from their telescopes, and I've been using that to try and improve focus with those data sets. And this video is an update on that, and it'll go through the functionality that's been added to focus as a result of their contributions. So thanks very much, folks. So probably to start with, the problem that folks on the forum have been suffering from is that if you have a scope with a central obstruction that creates donuts, providing you contain the range of motion of the focuser within a range that doesn't go into the donut zone, then generally focus works fine. And I guess you know, for most people, they've been doing that. There are some issues with it, but generally it's okay. However, the problem obviously is if the focuser does stray into the donut zone, then autofocus often fails, and that's, you know, for instance, if you're imaging unattended, then clearly that's a problem. The second problem that is related to the first problem, though, that has been reported, is that if you during an imaging session do something that kind of moves your point of focus away from where you're expecting it to be, then although you may have constrained your range of motion of the focuser to one that doesn't normally go into the donut zone, if the start point of focus is not correct, then again the focus could move into the donut zone, and that could cause a problem. So examples of that would be, for instance, if you have filters that are not parfocal, then when you swap filters, although you know, the first filter may be focusing fine, when you swap to the second filter, the start position needs to shift, and if it doesn't shift, then when you run autofocus, it will be into the donut zone, and then you'll get problems. So I think they're the two problems that this is kind of designed to solve. So let's jump in and kind of see how it goes. So I'm just going to illustrate the problem first off by running focus, and I'm just going to do that. So this just to illustrate the donuts here in this particular set of data are very, very pronounced. So the range of travel of the focuser goes a long way into the donut zone, probably further than, you know, from a practical perspective you'd probably want. So this is a data set from one of the developers that contains roughly 30 data points that have come from a Rejection. So what I'm doing here is I'm focusing using kind of standard parameters. So I've got the default set parameter profile, and everything else is kind of as you would probably have it set up. Now, as you can see, we've kind of moved into the normal star shape, the non-donut star shape range. I think it kind of anywhere from about points 10 and 11 outwards was donuts, and then from 10 or 11 sort of inwards at the moment we're kind of into the star shapes, and I think we're just about coming into donuts again as we move out of focus. So yeah, we can start to see the donuts forming there. So anyway, focus is, going to fail here because this is not a V-shaped curve, and there it is, it's failed. So I'm just going to stop that. So what I'll do is I'll just reset it. So that is the classic problem that I think folks probably with telescopes with central obstructions are familiar with. So what can we do about it? So there's a couple of changes in focus that will make a significant difference. So the first is this donut buster functionality. So tick that on. At the moment we'll just go with the default sub options, and I'll come back to those. The second change you want to be making is when you take this functionality, you will get an extra default profile, which is called Focus Default Donut. So you want to select that as well. So these two options, Donut Buster and the default donut parameter, are all I've changed, and I'll rerun this autofocus. Now, again, just to reiterate, we're a long way out of focus here with massive donut shaped stars. So you will get some noise, out on the edges if you go this far out. But nevertheless, as you're starting to see, the V curve that's being produced here is more of the sort of the classic V curve that you'd expect. So we're still in donut zone. I can still see these are donuts. They're just sort of disappearing now, and we're getting the regular star shapes. But you can see even in that donut zone, there's definitely a reasonable curve shape there that you'd expect on a V curve plot. So we'll just let this run through, but you can see that those two changes are making significant improvements. So I've run this on a few different folk scopes, or data sets rather, that folks have very kindly contributed from the forum, and these parameters seem to work on all of those. So you obviously, when you try this, if you have issues, just report them back and we can probably tweak the parameters a bit more, but I'm fairly happy that these will make a significant difference. As with all these parameters, you can potentially tweak them to get the best from your particular equipment, but hopefully the defaults will be pretty close. So this this autofocus run is now completed. It's obviously taken out the worst points with the outlier rejection. The rest of the points are pretty good. The R-squared's 0.99, and as I say, this has probably gone further into the donut zone than you'd probably want to do on a normal focus run. But it does illustrate the point that with these parameter changes, focus should work well with or without donuts. Okay, so how do you take these changes? So what I've done is I mentioned the major benefits are going to be obtained by ticking donut buster option on and selecting this default profile. So you'll get this default profile when you take the new software, so that should be available for selection. The other way you can get that is by just selecting the focus advisor, and there's now a new option down the bottom for set parameters, and if you update that, it will update the profile appropriate to your telescope type. So in this case, I've got this set to refractor. It's not going to set the donut profile, but if this was set to, for example, an SCT or a Newtonian, if I updated the parameters here, it would select the donut default profile. So, and it would reset that to standard parameters within that profile. So that's the other way of doing it. There is a third way, and that's when you set up a new optical train, and I'll just illustrate this by setting up a couple of trains here. I'll set one up called refractor. refractor on there. And I'll set another one up called Rejection. Now, one other thing that is important is when you set your telescopes up in the equipment configurator, it's important that you set the type up, because that's how Focus knows whether or not your telescope has a central obstruction. So, you know, if I set my Rejection up, then I need to basically set the telescope type to be a Rejection and not a refractor, for example. So I've set up two new optical trains here. Just get rid of that, move this in a bit. Now when I select, let's say, refractor, I'm going to get this for the first time. This is just a first use thing. I'm going to get this pop up saying, would I like Focus Advisor to optimize the parameters? I'm going to say yes. Now when I look in the options, what it will have done is it will have selected a set profile of focus default and donut buster will be off, which are appropriate settings for a refractor. Now if I, or when I select my Rejection optical train for the first time, I'll get another pop-up saying first use of the optical train Rejection, would you like Focus Advisor to optimize parameters? I'll say yes again. Now what it's done here is it's selected the set profile of focus default donut because it's a Rejection with a central obstruction, and it's ticked donut buster on. So it'll do that by default. That little confirmation pop-up has a 10-second timeout on it. So if you don't want Focus Advisor to do that, you have the option to say no to that pop-up. But I would suggest that for most folks, most of the time, having Focus Advisor do the defaulting is probably sensible, and then obviously you can go and check what it's done. And if you have some very specific changes that that you want for your kit, obviously you can make those changes. So that's how you take the changes. Probably the next thing is I will just go through some of these options, these other options. So these are more sort of tweaks that you can make that may make your setup slightly better. This time dilation factor is a way of varying the exposure per data point in the autofocus run. So as you move further and further out of focus, so obviously the HFR gets bigger, and what that obviously means is that the flux from the star is being spread over more pixels, and therefore the intensity, the peak intensity of the star is going to be less than would be the case when it's in focus. So in that particular case, you know, usually that works fine, but what you could do is you could take a longer exposure when you're further from focus to compensate for the fact that the intensity is dropping and it's kind of disappearing into the background noise. So just as an example, what I'll do is I'll set that to a factor of 4, and it's basically going to be a multiplicative factor versus the exposure that you set here. So just for purposes of time, I'll set that to 1. So what I'll do is I'll do a simulator run. So let me just set this up for the simulator. So we've set that to 4. Let's check everything else is going to be about right. I'll just do a small number of data points on this focus run, so you kind of get the point without it having to take too long. So all this is going to do is it's going to move to the furthest outward position, it's going to use an exposure of 4, which hopefully you can see there, and basically I'm using the old data set, so let me just stop that. One of the scourges of making videos. So what I failed to do there was reset. I'll just disable the save data set, and I'll go back to the simulator. So let's just do that again. So what it's doing is on the outermost data points, it's taking longer exposures, and then when it moves in towards the point of focus, it's sort of back to your whatever you'd set, the 1 second, and then as you move further out again along the curve, it's taking longer exposures. So this is the time dilation option. So that's, you know, that may be useful for some folks. So I'll just reset that. This outlier rejection, so this is kind of an aggressive sort of control that lets you turn this up or turn this down to, so the more aggressive you make it, so the higher this number, the more outliers will be rejected. There is some control in the software that hopefully won't let you do too many outliers, but obviously the more data points you take out, at some point it becomes a bit counterproductive, so you can't go too aggressive on it. But if you wanted to turn this up for some reason, then you can just use the control here to do that. So this is related to the refined curve fit option here. Now this last option I'll put on to illustrate, but this is designed to help with the situation where you are not starting focus for whatever reason from near to the focus point. So as I mentioned at the start of the video, this could be, for instance, where you have non-parfocal filters. So there are 2 ways within the focus module that you can now try to start your focus position from near to focus. So the first has been there a little while now. It's within that adaptive focus, and it's this adapt start pos. Now if you don't have adaptive focus set up properly, but you tick that box, what that will do is, if you have it ticked off, basically what will happen is autofocus will start from the current focus of position. So in a normal run, you run focus, you take some exposures, and then focus runs again. So in a normal course of events, what would happen is autofocus would start from the finished position of the previous autofocus run. So that's fine unless you have this, let's say, non-parfocal filter situation. Now what you can do is you can tick that on, and what that'll do is it will start focus from the last focus successful autofocus run of the filter in question. So if you change filters when you start autofocus with this option set on, it will start your focus run from the last solved position for that new filter. So that's a way of getting over the problem of where do you start autofocus from. If you have adaptive focus configured normally, then it would start from the last position of that filter, but it would then adapt that for temperature and potentially altitude changes in the same way as the normal adaptive focus does. So that's one way of changing the start position. And generally, I think within a focus run, that would work reasonably well. So I would suggest if folks have problems, they start off by ticking that and seeing how they go. Now there is another option I've put in within Donut Buster that will do a scan for the start position. So you can configure how many data points you want in that scan. I've set a minimum at 5 there, but you can do more. Obviously, the more data points you do, the longer this will take. So you probably need to figure out for your own equipment what an optimum number would be. And if you want to change the step size within the scan, not within the autofocus run itself, there's a multiplicative factor here that will be applied to the step size, the autofocus step size, for use in the scan. So if you wanted to use let's say a scan step size of twice the normal autofocus size, you put a factor of 2 in here, and if you wanted a scan to use, let's say, half the autofocus size, you put 0.5 in there. So I've ticked that on, so we'll just run that. So what it will say in the V-curve is scanning for the start position. Now I'd selected 5 data points, so that's what it'll do. It'll take 5 data points and it will look to see within there if it has a minimum, which it will, around here, which is 31,702. So there we go, 36,702 was the start point, and now it's going to run autofocus from that 36,702 data point. So this example is not perhaps particularly helpful because I'm starting autofocus from the point of optimum focus, so it's not really doing much, but as you can see, it works fine. If however I moved focus away a little bit, so let's put it there, and now I run that again, the scan will hopefully move focus back to around 37,000 as the start point. So it's taking the 5 data points to start. There we go. It didn't find a minimum within there, so it's going again with another 5 data points. I think this time it should find the minimum, probably around 0.7 there, that one there. Okay, so it's found a minimum at 36,732, and now it's going to start autofocus from 36,732, and then it's hopefully going to solve in a symmetrical way. So putting this option on, I think, should help with you know, the second of the reported problems that folks were having with Donut Stars. I think though, having solved the first problem, which is the you know, the Donut Buster functionality and the getting the set profile correct, may actually turn out to have solved this other problem as well, because if you do have a non-parfocal setup, you will now be more tolerant of starting off in the donut zone. But obviously it's up to you if you wish to try one of these 2 methods of adjusting the start position for an autofocus run. So that's pretty much it for the new functionality. Very interested in feedback. The functionality has now been merged into master, so for those of you that are able to take the bleeding edge software updates, then it should be available, and it will obviously be in the next full release of KStars. So clear skies.